Hello to viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about some space news of 1907-2024. Now, this is when I'm recording this video. So one of the biggest news, which is genuinely shocking for a lot of people, is that Falcon 9 had a failure. Now be mindful, Falcon 9 has two segments to it, two stages of its mission. Stage 1, dump the payload into orbit while you're getting paid for. So that's the stage 1. Stage 2 is landing. Now landing here worked as expected. However, stage 2 failed, which is shocking given the fact, think about this way, SpaceX Starlink 179. Yeah, SpaceX is on a whole different level when it comes to how many launch they have done, and given the fact that 300 launch has happened, which compared to everything else is like whoa. Like other rockets, other countries, other companies took decades to reach this point, and they're like just got here. So this is like significant. And again, after coming this large number, it's like also shocking. It's like whoa, what the hell? So on 12 July, something bad happened. So what happened? What do we know absolutely? What we know absolutely is second stage 2, basically oxygen started to leak. Now this oxygen, you can see, now many people originally thought maybe it's foam, insulation. Well, turns out as the video got, as we live stream was continued, we figured out, yeah, it is freaking ice. Because again, it started to expand. Now it's like, where the heck ice is coming from? Don't they have liquid oxygen? Yes, liquid oxygen, once it's exposed to the vacuum without any gas pressure, it expands too much, too quickly. It basically boils off. Now, boiling simply means you leach energy from the liquid state. Okay, you boiled off. Awesome. What happened to the liquid that you boiled off? It cools down even further. So it cools into ice. And when ice is falling apart and is going into the hot exhaust trail of the rocket, whoosh. So it was quite interesting. You can see all the that's happening. That's happening because that hot exhaust is invisible to us. But it's again, it's a reaction to cold ice. Is super easy to see. So that did happen. We know for a fact that liquid oxygen failure happened. Properties match. Everything makes sense. Liquid oxygen happened. Now, what was the consequence of this failure? Consequence was orbital injection failed, meaning it did not reach the point where it could do proper orbital inertia. Basically, engine could not ignite again. Now that led to, even the satellites were deployed, they were at the wrong place, so to say, basically. And even though we are talking about Starlink, which has its onboard ion engines, those ion engines were not designed for like almost fighting to the orbit. They had the velocity, but they did not have enough oomph where they could push through the drag, atmospheric drag. If they were peroxide based, maybe they could have done that, but again, that would have shortened their life so much, it would be like So that was loss of satellite. They thought they could overdrive the ion engines, maybe get some to the orbits. Yeah, that did not work out. So as of now, when I'm making this, second stage had a liquid oxygen failure. All the satellites are lost. The end. Mission is over, even though the booster landed successfully. Now, how could this happen? 300 missions, how could this happen? Well, Hesdy, we are dealing with reality. The reality has something known as probability. So there are two primary culprit that could have happened, or worst case scenario, both of them happened. So first is human error. Now, has this sort of thing happened in space where you have a rocket that is completely working and then just like poop? Yes, it just happened a few years ago to Russian rocket system, which was again same level of experience, hundreds of missions successfully, and then somebody installed a gyroscope wrong. Poof, happens. It's one of those things. We are human. We make mistakes. Things happen. Things slip through the cracks. Bad things happen. So that human error is one of the problems. Second is equipment failure. While you have to understand, booster is going through exponentially far more refined, basically progress cycle compared to the second stage. Why second stage is never coming back? The only thing that is coming back from second stage is the payload fairings. The first stage is full booster is coming back, so they can study it, analyze it year over year, model after model, after refinement after refinement. So they have damn sure that booster is gonna work. Like something catastrophically bad has to happen for booster to fail now. But the second stage, every second stage is first second stage, meaning they built it, they launched it, the end. So that creates a scenario where they could have a flaw in the design, which again, it's like 1 in 1,000 kind of scenario. It's like, okay, that 1 in 1,000 now just happened. So equipment failure, these are the two primary culprits that could have happened. Again, as the investigation will be concluded, we'll know what exactly happened. So what does it mean? Things happened, accident happened, what does it mean? It simply means Polaris Dawn, as of now when I'm recording this, has been delayed. Our ISS mission has been delayed. And FAA put whole Falcon 9 fleet on lockdown, meaning thou shall not fly. They are grounded. So they basically, FAA needs an investigative answer. It's like, what went wrong? What are you doing to fix it? That's all they need. Now, there is a scenario where they may be able to bypass it quickly, is that hey, we have 300 freaking launches. We have more than 100 launches a year. Nothing bad happened. Because be mindful, that's a realistic, real scenario where it's like something bad could happen. Like, it's just that day, that particular day, that metal was like, nope, I'm gonna crack. Things like that happen. It's a real life. Heck, jumbo jersey, even though they have so much maintenance done to it, there's still bad things happen. So there is a probability where it's like, dude, it's one of those things that you can never, ever, ever build a system that never cracks. That's why we have emergency escape system. So Falcon 9 failure, that was like, whoa, that could happen. Yeah, it did happen. So now we come to the more hopeful part, Starship. Now Starship V2 is slowly taking its shape. It's under construction, and the biggest change is the heat tile. Now heat tile is the weak link, but given the fact that last mission, meaning fourth mission, successfully touched Earth's surface without falling apart, even though it had literal holes in it, proves the design. That's the biggest surprise they have. It's like, think about it this way. There was a tiny hole in carbon-carbon shield of space shuttle on the wing lift. A hole happened, or the foam literally punched a hole. It re-entered, hot exhaust went inside, melted the wing out. Voila, bad things happened. Here, they had the same thing. It re-entered the atmosphere. Hot exhaust gas started to crack. Something happened. Something failed. Whether the hot gas directly pushed and cracked a heat shield, or heat shield failed and then hot, basically plasma started to cut through the wing. It did happen. However, even with that, the reason there were two things that allowed them to survive. First was blunt body re-entry. This is a blunt body, right? There is no aerodynamics. It's just a freaking blunt body. Benefit of blunt body is the shock is away from you. It does compromise control a bit, but does give you insulation, meaning you have your blunt body, how close that plasma wall will be, it's a bit further. So that does give you a bit of insulation property. Another part is stainless steel. Even though it's heating up, it can last at least 100 to 200 degrees Celsius hotter compared to aluminum. So that both of these two configuration allowed that puppy to survive. It touched water in one piece while it had a hole in it, while it's going through orbital re-entry. That's like, whoa. So that gives them a complete confidence is that if we reinforce the heat tiles, we done. Like design validation is done. We sorted. So what they are doing is turbocharging the heat tiles itself. The tiles are 2x more stronger, and just to make sure that because it's a reusable system, they have to design in such a way that what if tile fails, right? So it's not like space shuttle where it lands, they have to basically redo everything. It's like, what if tile fails and we want to recycle it very quickly? Well, put something behind it that is swappable also. So behind it, they are putting ablative sublayer. Basically, the felt layer is being replaced by ablative system. Now, why haven't they done it before? Again, they never reached to that point. And another thing is, they had to figure out whether they actually needed it or not, because again, that does add weight. So they may have to rejiggle some weight, some tonnage to save that. But if these two things are there, better generations of tile, better generations of ablative sublayer, that means even at a case of a tile failure, they should like easy GG able to land. That should happen. Another thing is flaps. That has the issue. This is the old flap design. You can see it's almost protruding into the air. So the idea with this Mark II is move it back. Basically that blunt body entry. So instead of like fighting with the hot exhaust, like I am the hot exhaust, yeah, you move like this. It's like, hey, just a little bit. It's just like they're not fighting it. You must have seen some videos where people, especially with ultralight aircraft, they put their hand out, plane starts to turn. That's all they are doing. They are little hands. So they're like, hey, don't go like this. Just like, so gentle. So you can see the hinges are much smaller, much more like upwards, much more. So they are compensating the design in such a way that it should shield them inherently from hot exhaust. And of course, they will reinforce the seams also. So these two things come, better design and better reinforcement seal with a better upgraded variant that should allow, hopefully, in Mark V, unless something bad happens while they are going to orbit, they should do a safe re-entry without any issue. I'm not talking about re-ignition and landing safely, but re-entry should happen without any issue. So that's what they're doing. And there has to be a lot of changes done to launch tower. Now, like, isn't launch tower sorted? Ironically, no. Launch tower still has issue. And I mean serious issue, meaning that did launch 4 times, all 4 times something bad happened. Now, the core structure was flawed in the Mark I variant, meaning the first time. Then they dig it up, reinforced it, turbocharged it. That's awesome. Water cooling plate, awesome. But the biggest weak link is the quick disconnects. It gets destroyed every time. Basically, every time when somebody like Starship Gazer, there are a lot of amazing individuals who are there, who are taking photographs. You can see almost after every launch, they have to go and basically repair the quick disconnect. It's like they could literally reach a point where it's like, sir, we have a reusable Starship. Awesome, launch it. They launched it. It's like, sir, it's coming back. Awesome, catch it. Awesome, they catched it. So let's refuel it. Yeah, we cannot. It's like, why not? So quick disconnect is destroyed. Like every time they have to replace the cryogenic pipe, and cryogenic pipe that can handle that kind of mass flow, not cheap. So they really are trying to nail down the design. So far they haven't. So that is also going through a lot of refinements, and they're also building second Mark II, basically a second launch tower that should hopefully have much better design. So Starship is getting a lot of work done. However, I do expect completely now that this will be delayed. I do not expect the launch to happen in August. Unless it's pre-done mostly, they will do it. But if it requires a lot of brain power, human power, they might as well be prioritizing Falcon 9, because Falcon 9 must fly. It's delaying some paid customers, really rich paid customer. Thou shall not delay really rich paid customers. So I do expect this to be delayed a bit. Now we come to Dream Chaser, another plane that was hopeful. It had a dream into it. Yeah, it gone through testing, which is good, awesome. Yeah, but the testing is happening very slowly. Consequence, they missed the mating season of this one. So what does that mean? That simply means ULA is not a more like a private company, even though it is. It's acting more like a government subsidiary, where like government is like, bro, we're gonna give you money, you have to provide services. And again, once you have provided our service, go YOLO, whatever you want to do. So that, who is that client? Client is United States Space Force, USSF. Now USSF requires national security assets. So national security asset meaning they cannot risk, like, CIA spying satellites on, like, oh, this is untested rocket. They cannot risk it. And be mindful, these are government level hululu, so cost is stupid. So they want to make sure the rocket which you're gonna use is tested at least 2 or 3 times. So ULA already did first time. Second time, the second testing they had to do, this was targeted for that, but it missed the mating season. Consequences, now this will be delayed. Now this is normal, natural, happens once in a while, where a rocket is ready but a payload is not, and then you delay it if it's like few months. However, in this scenario, because of the original delay of ULA itself, there is a lot of contract that has piled up, meaning they have a backlog. So Pentagon is like, nah bro, no, get going now. So because of the Pentagon's directive, they have to put a dummy payload on top and just launch it. They need that second launch ASAP, because again, the backlog is very serious, and these are some powerful people. These are the definition of powerful people. So fundamentally speaking, they have to listen to it. So they cannot be like, hey bro, relax man, 1 month, 2 months, no big deal. No. If they say launch it next week, it's gonna be launched next week. So that fundamentally created a gap. Basically, this rocket is ready now, but this is not. So they will now, like, what about third? Third is pre-booked for, again, main missions. So that created an issue where they are stuck. So either, unless this starts to being mass produced like SpaceX, where it's like, we good, that's not happening. So this will be literally stuck in the line waiting for an empty spot, which, given how delayed this is, it could be few years at worst case scenario. Now of course ULA will try their best to, like, chill down basically Pentagon and be like, hey man, brother, relax brother. And again, this has some serious potential, again, from national security point of view also. So it's like, let's arrange a bit. And again, Pentagon itself would have like extreme priority that we need it now, versus some like, yeah, okay, if we can delay it like few months. So I do expect this to be launched, but the probability of it launching 2024, it's almost zero at this point in time. So that's the problem at this point in time. And be mindful, ULA cannot piss off USSF under any circumstances. So, and because they basically, Shiaran space company, they designed everything for this rocket, they're stuck. If they design with Falcon 9, they're like, bro, who cares? Although ironically, even that Falcon 9 would have caused delay, but I'm reasonably sure it will be like a Falcon 9 will start to fly in next 2 to 3 months maximum. So Dream Chaser is still stuck at dream chasing stage. Now we come to another sad part, is Viper cancellation. Now this puppy, it's almost built, 80% built, but it has to be cancelled. Now this was almost a flagship mission for lunar exploration, because remember, so far in the lunar exploration game, everybody's like water. India is like water, NASA is like water, China is like water, and it's like nobody has touched the goddamn water. So this was the first mission, was like, no, I can touch it. So this is a mission that was designed for long duration, meaning it had enough battery, enough solar power that if things go well and the placement was done correctly, it could brave the lunar night. It should not freeze, should not die. It should survive the lunar night. And again, that's not that hard to do if you have access to radio isotropic generator or radio heating elements. For some reason, it did not get the heating elements. Isotropic generators is very expensive, but the heating element is not. But I do not know why they did not get it. But again, that does allow cost to be lower. So they rebuilt this awesome. It has a drill, a long drill, like a really this long drill. So that drill is supposed to go there in the lunar, basically parts where sun does not shine ever. That go there and actually drill it. It had lights, cameras, everything to actually drill it and to actually get vapor out of it. So the idea is if there is wetness in the rocks and you drill through it, breach the surface tension, it should start to come out. So that was the hope. That's the whole point. This is supposed to touch water. Everything else is like we have sensor data. No, this is like we touched water. So that was the whole point of it. However, it's built again according to NASA itself, and NASA was doing surprisingly amazing job when it comes to actually showing how this was built. Like they had live streams of this I think monthly, where they were showing like how we are building it, how the wiring is done, like surprisingly amount of detail. Like whoa! You want to learn how things behind the scene works? Go watch it. It's awesome. So rover is 80% finished. Now you're like, okay, if it's 80% finished, why they are cutting it now? Well, a cost increase, that's the first thing. And the second thing is delayed to launch. Be mindful, this is already delayed. As in what the original timeline is lol. It's I think 2 years behind schedule. So original timeline is lol. The original price tag is lol. And there is a serious tiny risk that they have is that even the promised date that they are giving, they cannot guarantee that it will be launched. It could delay even further, and on top of that, risk of further cost growth, meaning they can go to Congress and be like, hey, $80 million, we can finish this. But I think NASA learned it that they do not have good CA. They do not know how to do math when it comes to cost. Because again, this is the same thing that happened with James Webb Space Telescope. That puppy is supposed to be $500 million. Like, wait, what? Yeah. That's the original price. That's how they got the approval. Then they're like, no, sir, mistake, sir. It's actually $1 billion. They're like, government's like, who cares? Just 1 billion. Then it's like, sir, minor mistake. $3 billion. It's like, okay, it's starting to get painful. Then it's like, sir, minor mistake. $7 billion. It's like, what? Then it's like, again, sir, extra mistake. $10 billion. So there is a probability of cost overrun, and NASA has messed up enough. And be mindful, Artemis mission is also messed up, which is also costing over drain on the tiny budget they have. So again, whenever this sort of things happen, when giant projects cause giant delays with a giant cost overrun, tiny projects are compromised. So this is the tiny project that is being compromised. And again, this is literally the same thing. People ask us like, oh, James Webb Telescope should have been cancelled. It actually caused cancellation of multiple observatories, not one, multiple smaller ones. It caused that. So same thing is happening here. Artemis is literally causing, because of the over cost run and delay and all that, it's causing destruction on tiny projects. We are just seeing it so clearly this time. And Congress is cutting funding, so they had to do it. So I do not blame them, but it's like, I think they should have created a scenario where it's like, hey, is anybody wants to do this privately? Like, we have built it, do it privately, and we're gonna give you a very small amount of money. Like, almost do it private mission itself, maybe. Because remember, this was a huge thing to actually touch water. So far, everybody is like, water. No, this is like, I touched water. So again, it has been cancelled. Let's see what happens. Another sad news is deorbiting ISS is now confirmed, as in like people are putting money into it. So ISS is no longer safe and sound. What does that mean? That simply means ISS has gone through fair share of brutal reality. What is the brutal reality? The biggest hurdle you have in space is radiation. Assume that your structures can withstand radiation, which is not that difficult unless you're talking about neutron radiation, which hopefully there's not that much. Alpha, beta, gamma is minor inconvenience. You have neutron radiation, that puppy changes elements. So that's a very big issue. That's not that big of an issue in ISS. However, it is going through enough radiation. Side effect of that is it also going through day and night cycle multiple times per day. And that is the most painful part for ISS. ISS is a white body because it's designed to be such a way that it does not heat up too much when it's going through the sun side and does not dump too much heat outside into the vacuum. So day and night temperature swings should be very minimal. However, we are talking about a structure that has to do that every day 20 times for decades. So you can understand that no matter how good material you are using, no matter how good your insulation is, no matter how good your joints are, it's gonna start to fatigue. it has reached that point. What does that mean? That simply means all the astronauts, they're going there, we're going to do this 20 missions. Awesome. They go there and it's like after the mission is over, people are like on ground, how many you did? Yeah, 5. It's like, what happened? Well, we had this ammonia leak, then we were trying to repair that leak. Then we had this space chute failure, then we were trying to repair this. Then we had the power failure, then we were trying to repair it. So that's the reality right now. It's like, rather than missions, rather than things being done, it's just like, let's keep this flotilla alive. So boat is already sunk. They are trying their best to not let it sink further. That has happened. And Russia has already pulled their commitment, meaning their commitment has a dead expiry date. They will not touch this beyond this point. So something has to be done. And it is too goddamn expensive to maintain on their own. So what NASA to do? Now be mindful, this is a huge puppy and this is in low Earth orbit, meaning if untouched, if nothing is done, it will crash into Earth. And because of the huge size, mass and tonnage, we are talking about around 400 to 600 tons, this puppy will touch Earth, meaning it's going to go vabam. And if you do not control it, it can vabam any random place. So that is not allowable. So SpaceX get $843 million. I'm like, that's a lot of millions. So basically they have to make an upgraded variant of this puppy or use Starship. Again, that part is not sorted yet. Most likely they will make an upgraded version of that with more booster power and more thrust capability of like vectoring the system. Because again, not only you have to slow it down, you have to also slow it down and while trim the trajectory, so to say. So they have to do that. Only then it can be allowed to safely re-enter the Nemo point, a point in sea where nothing is, basically is the most isolated point in sea and everything crashes there. So that's the whole point. Now many people are against it and there is a genuine reason for that. The reason is that it's the world's first space heritage site. This is the first site where multiple countries came together and actually worked. You are talking about multiple countries of European Union, Canada, America, Russia. So overall, it's a significant, it's like a world trade like kind of deal. It's expensive, it's serious, it's important. In terms of heritage, it's far more important for humanity compared to all other grand heritage site. Why? All other grand heritage is earthbound. This is the only thing that we have spacebound. So a lot of people are like, dude, that sort of cost is that either you are wasting that money or you're just like force stuck into like, if that sort of money you are spending, you should be able to push it into higher orbit. And yes, there are graveyard orbits. Yes, there are other orbits where you can put in like, and all the junk issue that you have so many space junk, those are issue in low Earth orbit, not in higher orbits. So there are orbits where it's like completely void, like almost empty. So you can put it there and be like, it's like, what's the point? Well, if you put it there, it's an archive of humanity. And archives have this weird habit that they are valueless when you make them. They become priceless as time passes. For example, if I have archived all the photos early days, like I was so old that there used to be Sony Ericsson mobile phones. Yeah, I had Sony Ericsson K810i. I took photos. Thankfully, I somehow archived it in Google Pixels. No, there was a different photo software name back then. I archived it. Now it's priceless because, again, that's how it happens. So if humanity archives this, this is a priceless thing. And again, there is another requirement of that. We need to figure out the legal structure of what we're going to do with things in space, like moon and all that. This could be a perfect starting ground of it. How the heck are you going to make sure that China does not loll around it? How do you make sure Russia does not loll around it? How do you make sure other countries itself do not loll around it? All of those things require legal framework. Perfect legal framework. Start with this, figure things out, and then you move forward. Because again, Apollo mission did not require an isolation system because again, there was nobody else that could even go there. Now there are countries that are trying to do, for example, China is like, one has to figure out how we're going to maintain the outer space. And ironically, even though we are really bad to human on each other on the surface, we are surprisingly good even in space. Example, Russia and America working together in space. So it is significant. It is what we classify as priceless artifact. And the older it gets, the more priceless it becomes. So it's in our best interest from a humanity's point of view. That is like, hey, let's just spend some money. Let's not be short-sighted. Let's put it in a safe archive. And again, 1,000 years from now, it will be like, whoa, humanity built this. Like imagine what we are seeing Starship being built. You know, assume it works. Assume Starship works. What does that mean? That simply means we'll have a space shuttle that is actually the space shuttle, like a bus to space. We can go there. We can build even grander things, even more amazing things. Spinning habitats. Now we'll have artificial gravity. Now children can go there. Now we can have that. And then you know, few decades from now, they're like, look, this is how we got it. Like think about this. Like what is the price of the first Superman comics? It's priceless. So same thing. So again, I do see the both of the points. It's like one is cheaper, do it now, and another is like we have been doing it. That's why we are in such a mess. We need to archive this thing for the future generation. So this was my presentation on the news that happened recently that was interesting. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.